Good afternoon, by which I mean good morning. Fancy meat computers. How's everybody doing? Hopefully we get more than 8 people showing up. Have you all been good since yesterday, when last we spoke? It is my full intention to finish this slide set today, just so you know. I'm so unprepared for 2P04. He blazed through 4 chapters and 3 lectures last week, and only now released the practice problems. Oof. Can we please extend the due date of A3? We have 3 midterms this weekend. Okay, let me take a poll. Nah. Can we have the baby as a guest lecturer? I feel like he'd do a good job. Yeah, he's, you know, he only makes a few sounds at the moment, but, no, I said baby reveal at 1,000 subs, and you guys haven't hit 1,000 subs yet. Okay. I'm just going to leave that up while a few people more filter in. Well, see, the problem is if I extend A3 that long, that means that people don't even have to think about it until after the test. And I just want to say to all of you that the best preparation for the test is going to be assignment 3. So, I did my job. I'm subscribed. Where's the baby? I want that on a t-shirt, actually. Could we have that on a t-shirt? That would be awesome. So I'll tell you why I've been hesitant to extend the due date of assignment 3. The test at the end of the weekend is going to be... It's going to need you guys to have done assignment 3. So if I extend the due date a full week to next weekend, that means you gotta pick up your socks here, it's basically I would have to move the test too, and I just don't want to move the test because it's already so late in the semester for it. For God's sake, we were supposed to have this 2 weeks ago. But, Are there going to be questions as hard as, the shell sort question on the midterm? No. Shell sort is, peak difficulty for assignment 3. I don't believe that I'm going to be putting any questions on the test that are that hard. Exam is fair game, though. Just scrap the midterm. Ha! No. That would be unfair to people who assumed that the assignments could be safely ignored because they were only worth 8% each or whatever, how much they are. I found that out, actually. The first time I ran this course, I wanted to do two midterms, and I scrapped the second one. And I found out that a bunch of people were relying on the fact that the assignments weren't worth as much, and they thought they could ignore them, and then they couldn't ignore them, and then this was my problem. Can you have a small hint on how to start question 3? Question 3 is the shell sort problem, I assume, right? Yeah, I can talk about that. It's an assignment, so I can talk about that. So, shell sort. Well, first of all, my number 1 recommendation for doing the shell sort problem would be to rewatch the lecture where we covered shell sort in lecture. We've already talked about this algorithm in depth, right? The next thing to do is to implement it. So essentially, I'll roughly and briefly describe the shell sort algorithm to you one more time, this time in the context of dynamic memory allocation, right? So can you also get a hint on how to solve the midterm? No. Yes, I'll give you a hint on how to solve the midterm. Do assignment 3 before the midterm. So remember what the shell sort algorithm does, right? We take the thing, we take the array, we slice it into chunks, right? We do a slicing operation. It's actually, if you guys are familiar with the Python slicing operations, they're actually, it's actually kind of similar. So, Python 3, if we had, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. There you go. You can tell I have a young child, eh? If you were to do, if you were to extract H gaps of, 5, for example, that's kind of a funny word. This would be your first H gap, this would be your second sequence, this would be your third sequence, this would be your fourth sequence, that would be your fifth sequence, And if you did any more than that, you'd just be repeating this guy, so you stop there, right? So these are your slices for an H-gap of 5, right? So that's the first step, is to write an algorithm that slices the array correctly, right? So using dynamic memory allocation, what you can do is you can allocate a new array that is the size of this guy and store that in it, sort it, put the elements back, and then Bob's your uncle. If you do it that way, the advantage of doing it that way is that you can then pass the array itself that you have dynamically allocated as to the subsorting algorithm, which should be insertion sort. So you don't have to come up with like a funny version of insertion sort that takes into account H-gaps. You can just pass it an array and use it like you would use it for any other array. Take the result and then put it back. That's why dynamic allocation is a useful thing in this instance. It is possible to sort this. It is possible to do the shell sort algorithm without it. But if you're using a pre-existing insertion sort algorithm, that is how to do it, I would say. So we would make 5 arrays with those 5 elements, or 1 array with 5 arrays in it. I would say make 5 arrays. Well, see, this is where the trick comes, right? Because how do you know how many variables to set, right? So to some degree, you need... So that's layer 1. Layer 2 is managing the memory of these individual arrays. If you want to do it one at a time, I would say that's the easiest thing to do, right? And you can you don't have to break it up into all 5 of the arrays all at once, right? You can, extract the first array, sort it, put it back, extract the second array, sort it, put it back. That way you only ever keep 1 array open, which means you know how many arrays you need open, right? How many subarrays. It's only ever 1, right? And that's easy to deal with. If you want to completely decompose the entire array into subarrays all up front, the problem that you then run into is, well, how many subarrays am I going to get? Well, it depends on the size of the array, and actually, it doesn't depend on the size of the array. It depends on the what the size of the H-gap is, right? In general, it's going to be the size of the H-gap. That's how many subarrays you're going to get. But the problem is, if you're going to do it that way, you have to find some way of managing all of that memory. I would say the easiest way to manage all of that memory is to use an array of pointers, where each pointer points to a dynamically allocated subarray that contains those elements. So I think it's overwhelmingly easier to debug and everything else to just, add a loop that performs the subsort on each one of those individually extracted, rather than extracting all of them up front. That's how I would approach it. So I think that's more than a little hint for the shell sort problem. Hopefully that's a good one. So, according to the poll, I'm sure more of you would ask, I'm sure people would ask for more days than 2 days if I had put the options in the quiz, or in the poll, but I think I'm going to, I don't want to extend it by more than 2 days. So 2 days it shall be. We will have a 2-day extension on assignment 3. However, if you don't do assignment 3 before the midterm, you'll be sorry. So just keep that in mind, okay? You've been given fair warning. So, so let's talk about computers and junk. Yeah, it doesn't sound like the Tiny Meat computer would be down for giving a lecture right at the moment. I think his mom is trying to get him down for a nap. So, anyway. So field widths. This is where we left off last time. So remember we were talking about formatting tags and how all of the awesome and interesting things you can do with them. So, have you ever been bummed out because getting C to print a table of values with properly aligned numbers is hard? Fear no more. Inserting an integer value between the %sign character and the format specifier sets the field width. Data will normally be right justified within this field, unless you set it otherwise. Field widths may be used with all format specifiers. If your field width is too narrow for your data will overhang the specified width rather than being truncated. So, for example, let's see printing with a field width of 4, the numbers 1, 12, 1, like 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, and then also the negative versions. Let's see what that looks like when we print it. So, we up to 1, 2, 3, 4, everything looks fine. And then, when we hit 5, we have overhang. With negative numbers, since the negative sign occupies 1 character's worth of space, you can see by the end of it we are overhanging by 2 characters rather than just the 1. So, field widths with precision. We can specify various things for different data types using the .x, where x is an integer, format tag. When applied to integers, leading zeros are included instead of spaces to fill the field width. When applied to floats, this controls the number of decimal places that are displayed, i.e., the precision. When applied to strings, this sets the number of characters to display. The rest of the string will be truncated. So, the S tag looks for a terminating null character. If you aren't careful, %sign S can produce a segfault. Using the S tag instead of the C tag by mistake can also cause this. So if you're trying to print an individual character with single quotes, then, imagining like a single character doesn't have null termination, the S tag looks for null termination, so if you give it something that doesn't have null termination, segfault. Possible segfault. Specifying a field width is an effective countermeasure against non-null terminating strings. So the way out of having the string tag go into a segfault is by saying only display this number of characters. If this is done intelligently, then you will constrain the field, you will constrain it to, the size of the string that you're trying to print. And if you do it unintelligently, it's still very probable that you'll constrain it to the size of your working memory, and you won't go off into Never Never Land. In Peter Pan, Never Never Land is a place that you want to be, but in computing, Never Never Land is a place where segfaults dwell. It's never, never go there land. So let's be precise about this. So if we have the integer 876, if we have 0.4 and 0.9 here, the difference is we display the leading zeros. When you're doing this with a floating point number, in double precision format, 0.3 and 0.3g and 0.3e will have the following formats. So we have, it displays to 3 decimal places. Remember that floats normally display to 6 decimal places. Even when we're in floating point notation, we're displaying to 3, even in scientific notation, we're displaying to 3 decimal places. And, oof, that's ugly. I'm sorry about that. And for strings, if we limit this to 11 characters, you can see that we can turn happy birthday into happy birth, which, let me tell you, as a person who has experienced that particular process within the last year, when it is finished, you are happy that it is finished, for sure. Well, I guess I experienced it by proxy, but, it doesn't feel like that when you're there. Anyway, so, field widths and precisions may be used in conjunction. So if you display to 9 characters 6 points of precision, then you get 2 characters in front. These are normally spaces, but you can't see spaces, so I put underscores in. I like how your string got cut off on the string cutoff slide. Yeah, tell me about it, eh? Could you put a variable that was calculated in the function earlier in place of a number instead? Oh yeah, all of this works on variables. Yeah. All of this works on calculated variables. There's no difference with respect to printf between a literal and, something that's a result of your calculation. Absolutely. So, in addition, there are a number of flags that may be included to modify the print format. So if you include the minus sign as a flag, this means you're wanting to left justify the output within the specified field. If you include a plus sign, this means that you want to display a plus sign preceding positive values and a minus sign preceding negative values. This is the type of option that you would want if, for example, you were in finance, when it's important to know that this is positive, this is negative. So if you don't know what the precision is, you should just use dot. No, you should just not include the dot. Oh, I'm still a bit confused about %x, what x does. Doesn't it affect the number of digits? Why does 4D still output 1, 2, 3, 4, 5 in the example? So, because these things behave differently depending on what data type they're being applied to. In strings, it's truncation, but on integers, it's just, integers allow overhang. So, this happens because with integers specifically, specifying the field width allows overhang, but it doesn't with strings. The rules are different for strings. %x is hexadecimal, so you will display things in hexadecimal format, like this, using that crazy combination of the digits 0 through 9 and the letters A through F. When I referenced x here, and perhaps I shouldn't have, I meant this is like some integer x. Like x is in like a variable in calculus. So, if you put a space in, then it prints a space before a positive value and not with the... so rather than printing a plus sign, it prints a space. You do that if you want your positive and negative numbers to line up perfectly. If you use the pound sign, or octothorpe, or hashtag, or comment symbol in Python, we prefix 0 to the output value when used with the octal conversion specifier O. Prefix 0 or 0x or 0x capital to the output value when used with the hexadecimal conversion specifier. So basically, octothorpe just puts, the whatever the base is in as a prefix. And 0 pads the field with leading zeros. So for integers, percent sign some value, some integer x, just specifies that we want the last digit to be x spaces to the right. Yes, but if the integer is too big, it just hangs over. Yes and yes. Yes. So, we can also use scanf to constrain what we're reading in as input. So, we can use format options to modify our inputs as well as our outputs. If we wish to only read specified characters, we may use a scan set using square braces. The formatter will stop at the first element not in the scan set. The scan set may also be inverted by making the hat caret character the first element of the scan set. Sometimes the string you are reading will contain characters that can be safely skipped. The format specifier option star tells scanf to skip the assignment procedure for the specified format tag. This may be used in combination with other options to specify the type and number of characters to be skipped. So for example, this example reads 8 vowels, lowercase vowels, right? So so scanf is kind of interesting. It reads in the data from standard input, and it keeps it will process as much as it can process, and then it'll stop, right? So in this case, it reads in a maximum of 8 lowercase vowel characters, and stores them in a character array, which notice has space that's been left in it for null termination. So when we enter into standard input, this string, once we hit H, we stop reading that input. And you'll notice that that is actually less than 8 characters that's been read in. Also, for example, and this will have particular application to assignment 4, so if you're making notes about that sort of thing, please highlight this slide. You can use wildcard characters. So if, for example, month, day, year has been entered in with dashes, you can separate out month, day, and year by having 3 scan tags inside of the format string with like a wildcard tag in between each of them. That will apply wildcard to like 1 character between each of these values. So basically what happens here mechanically is scanf examines the first tag. It's like, I need an integer. It reads up to, it determines that an integer is no longer occurring. Then it stops. Then it looks at the next scan tag. The next scan tag is like, throw away 1 character. So it throws away 1 character. The next scan tag is, I am looking for another integer. So it scans through it. It scans through the string, the remainder of the string, for however much integer it can pick out. It does that. It throws that away. Then it's like, okay, 1 more wildcard. Throw 1 miscellaneous character away. And then it's like one more integer. It's like, okay, one more integer. And then it's done. So this is a really cool way. You can also just include, like, if you want scanf to throw away like a dash specifically, you can just put a dash in and not escape it with the format tag. Any questions about that? Because if not, we're going to move on to file I/O. Okay, I'm going to assume there are no questions then. We'll just keep moving. So, file operations. I assume you all did file operations in 1P13, right? Have you guys done file I/O before? That becomes important. Basically, this section is going to assume that you guys have done file I/O within the context of Python. So. Good. Well, one guy has done it. All right. So. Oh, that's funny. It's like the following 5 functions and then 7 functions. I need to proofread these bloody slides. So, the following functions are the essential operations for reading to and writing from files. fopen, fclose, fscanf, fread, fwrite, fprintf, and feof. Using these files, using files in C requires knowledge of the file structure, which is defined in standard.io.h. So by importing stdio.h, you've already imported all of these functions. Think of it as a structure containing all of the information relevant. Wow, this slide really needs work. I'm sorry for this, guys. All of the information relevant to a file that is currently being streamed. So we're going to talk about structures next week, possibly tomorrow. This section assumes you at least vaguely remember how to do this in Python. So, in general, the procedure is you open up a file stream by opening a file. You perform operations over that file stream. When you're finished, you close the file stream. So, opening a file stream requires an invocation of fopen. So, fopen takes a constant character file name, or a constant char star file name. So it takes a string, and it takes a mode. Mode is expressed as a string, just like the same. So this is roughly exactly equivalent to the open function in Python. As you may expect, file name is a string containing the name of the file to be opened. The file may be specified by either absolute or relative addressing. The mode is a string specifying, among other things, whether the file will be opened in read or write mode. The output of this file is a file structure pointer. That is a pointer to the data structure file of the file type. It contains all of the information required by C to be able to process the file. So in Python, we call this a file handle, right? It's the return result of the open function. You don't have to worry about direct manipulation of this pointer. It is only interacted with via the file operation functions. So basically, you don't have to do anything with it except pass it where it expects to be passed to these various functions. This is roughly the equivalent of calling methods on the file handler object in Python. So, the following are our modes. We've got R for open an existing file and reading it. W for create a file for writing. If the file already exists, this discards the current contents. So W is an overwrite operation. A is append. So it opens a file for writing and it basically it keeps the existing contents and sets your file pointer at the end of the file so that when you add stuff, it adds it at the end of the file. R plus opens an existing file for update, so for reading and writing. W plus create a file for reading and writing. If the file already exists, discard the contents. And A plus opens the file for reading or writing. So plus is like a read/write operation. You don't have to worry about those. If you can get reading and writing working, then you're good. You only have to worry about the first two of these. F close, but no cigar. That's a terrible... There are some truly awful puns coming up in this next section. Just warning you. Just as a dynamically allocated pointer needs to be freed when it is no longer needed, a file stream must be closed when you are finished with it. It's even more essential to close a file stream than it is to free a pointer. It's pretty straightforward. All you have to do is call fclose on the file stream object, or the file stream structure, the pointer to the structure. Takes the file stream as an argument. This returns 0 on success and the end of file character on failure. So basically, if you say equals 0, you can check to see that this worked. fscanf is difficult to write a pun for. If anybody can think of a pun for fscanf, I'll write it down and maybe update the slides with it when I fix all of those typos. So, if you want to treat your file like you are reading information from standard input, consider using fscanf and fprintf. So, essentially, this allows you to spoof your file as if it were coming from standard input, and as if you were writing to standard output. While the first argument is the file stream we are reading from, the rest of the arguments are used exactly and precisely as you would use in fscanf. The return value is the number of input items successfully matched and assigned, i.e., the number of format specifiers in the format string that were successful. So, fscanf allows you to leverage the power of format specifiers for the purpose of reading files. This is extremely useful. fprintf is equally difficult to write a pun for. Some of these puns aren't even puns. So fprintf, same deal, but you're writing instead of reading. Writes characters into a file in exactly the manner you would expect. The first argument is the file stream. It returns the number of characters written if successful, and a negative number upon failure. Enough said. Read any good books lately? If repeatedly invoking fscanf isn't your style, perhaps you'd prefer writing chunks of files directly into arrays. In this case, this is the function for you. So we've got a void pointer here, a size, another size, and a file stream object. So pointer is a pointer to the memory block you're writing to. This needs to be at least as big as size times nmemb. So basically, like what's not being said in this slide is you would you would declare a pointer with a you would declare an array or allocate memory to a pointer that was at least as big as the amount of memory you want to read in from the file. size, the second argument, is the size in bytes of each element to be read. So using size of would be a good idea here. So if you're reading integers, you do size of int. If you're doing doubles, you do size of double, etc., etc. nmemb is the number of elements to be read, each the size of size. And stream is, of course, the file stream. fread returns the total number of elements successfully read. And in reverse, fwrite takes a pointer, a size, nmem, and a file stream. So it takes exactly the same things, but it does the exactly reverse thing. It takes the same arguments, but it performs the reverse operation. Pointer is a pointer to the array of elements to be written to, instead of written, Pointer is the array of elements to be written, not like blank memory to be written to, but it contains values that you want to write. Size is the size in bytes of each element of the pointer. So, again, size of is a great option here. nmemb is the number of elements to be written. So it should be the size of your, it's the number of elements in this thing you're passing in. And stream is obviously our old friend, the file stream. fwrite returns the total number of elements successfully written to the file stream. And then we have FEOF, FEOF World Cup. So, all this reading from files is fine, but how do we know when we're finished? So, FEOF is used to test to see if the file stream has reached the end of the file. Input is the file stream, naturally, and output is a non-zero if the end of the file has been reached, and 0 otherwise. So if FEOF of your file stream is equal to 0, then you're not done yet. So here's an example. Let's say we had, I get that one, right? It's like FIFO, but it's FEOF. Yeah, there we go. I told you the puns were pretty terrible. So here's an example. We have our file pointer, which has been declared up front. This is a strange thing. I don't normally like put assignment statements inside of if expressions. That's like, I would not recommend doing it this way. But you know what? This might be easier if we just if we did an example. Example time. See if I can get it done in the 10 minutes that we have. Topic, what is this? 7? Well, okay. Edit io.c. There we go. So, first, of course, with any C file, include stdio.h int main return 0. So, first thing we want to do is we want to create a pointer to a file stream object. So, file star, I'll call it FH for file handler. That's sort of Python notation, but that's how I'm going to do it. Yes. Well, no, it's a quote from the famous movie Titanic, right? That's a movie quote. You know, if it's not safe for work, that's just your imagination doing it, you know. But anyway, so let's open the file then. So fh is equal to fopen. Let's just say, I think topic 7.c. All I want to do here is just like echo it, you know, do that in read mode. If fh is equal to null, then return -1. Sure. Let's I don't really want to have to figure out how many characters are in that file, so I'm just gonna declare a large one. So char buffer, give it 1,000. Assume that's gonna be big enough. I'm gonna use fread. So fread buffer size of char. I'm going to just be reading it in as character data. Size, well, 999 maximum. And file stream would be fh. Then I just want to print what I got. There we go. So let's see if this compiles. Nope. Oh, silly me. I put a dot, period instead of a comma. Silly me. There we go. See? Like, 3 errors created because I put a period instead of a comma. Always, always, always attack the error list top to bottom. Always. So, a.out. And there you go. Look, it just printed it. It just printed the contents. Ta-da! So that's one way of doing it. But let's we have a little bit of time, so why don't we use some of the other stuff as well? So while feof fh does not equal, or while it equals 0, because if it's not 0, then we have reached the end of the file. This will be the old way. What's that buffer doing again? It's just the memory that we're storing the characters of the file in until we display them, right? It's like, that was a very simple program. All it was doing was reading all of the characters that comprise that file into memory and then echoing them back into standard input. So the buffer is just like where you're keeping stuff. So fscanf, let's say I want to read the first 20, let's say I want to read this in 20 characters at a time and display it 20 characters at a time. Just, you know, for the sake of interest. Scanf, and we got to give it the file handle. And we got to set that to the buffer. There we go. Oh, and I did the stupid thing, which I said never to do. Fclose. You're supposed to close the file handle. There we go. Ay, ay, ay. Alright, let's see if that compiles. Ah, it would be helpful if I could spell things correctly. There we go. So, you can see that this is basically reading in everything in there, but like omitting the spaces, which is kind of strange. Yeah, it kind of, that's an interesting result. It kind of just compressed the whole thing into like, that's interesting. Why is it omitting white space, I wonder? That's probably a fscaf, yeah. That's probably a feature of scanf, is it eliminates white space. So there are actually different use cases for fread and fscanf. Fscanf apparently destroys all white space. So if you need the white space, you probably should be using fread. But yeah, okay, so that's, there you go. There's an example. It's actually not a whole lot of characters when you compress it down like that, eh? But, and you know what the fun thing is? Because this is C, this is still, I think, well, with the possible exception, I think the, preprocessor commands have to be on their own line. But aside from that, this is still a valid C program. Assuming there are no comments. Well, maybe not. I think you need, like, spaces in here. Yeah, I'll take that back. This isn't a valid C program. It needs it needs more spaces than this. But, anyway. Can I please see the code again? Yeah, sorry. There you go. Any questions? I will display the end of the slides comic in that case. There you go. How do you find time to relax as an adult without feeling like relaxing means falling behind on other things you should be doing? If anybody in the chat has the answer to that one, I'd love to hear it. Yeah, no, that's... So... That's kind of an aspect of, I think I popped a rib out of place there. Ouch. I subluxated a rib. So, yeah. So there's this thing called, so if you subscribe to the Big Five, theory of personality, there's this thing called trait conscientiousness, which is basically like I've been trying to understand how it manifests itself psychologically, because it's an extremely good trait to have. It means like it's basically your industriousness. It's how willing you are to do work, which is an extremely important thing if you want a job, right? Or to do well in society. So I've been thinking about it, and it's like I think it's like part of it might just be like you just don't feel good unless you are accomplishing something or working on something. So yeah, I think that's part of it. But when you get sufficiently old, you just stop giving an F about things, and it's like it's kind of like F you world, I'm gonna play Dragon Quest for an hour. You kind of have to get to that point in order to survive. But anyway, I think I'm gonna sign off here. Especially because I just injured my rib cage. But anyway, yeah, it's like welcome to the real world, kittens. You know. Let me tell you something about the real world. Life doesn't get easier once you get out of school. I'm just gonna say that right there. But it's still worth it. It's still worth it. I used to like doing nothing, but university burnt that out of me. Yeah, what you have to do is you have to examine those elements of your personality which are holding you back, and then be willing to let go of them. That's like if you take a look at Jungian psychology, that's like the archetype of the coming of age story, or the archetype of the rite of initiation. Like, you know, like various cultures have initiation rites, and what the, like, you know, in some cultures it's like you have to jump over a fire or something, and that's symbolic of the burning off of you of that which you need to burn off in order to grow into your new role. Like, as we mature and age, our personalities, like, in order for the better parts of us to be able to develop as personalities, you have to be able to, every once in a while, burn off the dead wood, you know? Like, and people do accumulate dead wood in their personalities over time, you know? You have to be able to let go of the things that are holding you back. But yeah. I still like doing nothing, but university gives the ultimatum of do it or fail. Yeah, well, you know, what's the worst thing that happens if you don't do the assignment, right? You get a bad mark. You could probably still pass the course. You know, it is actually true that like 2 years after you graduate, nobody will care what your grades were anyways. Yeah, it's like, try not to be too personal with it, but like in my position as a person who's lecturing, what if I just, you know, decided that, you know, life was too much for me and I didn't do my slides for 1 week, you know? Yeah, you know, it's like getting a bad grade is one thing, but if you don't get your work done at a job, you risk losing that job. Losing that job means losing your livelihood. It means not being able to pay rent. It means not being able to feed your family. So, you know, it's like, you know, well, is the work like is your work schedule as hectic as a student's schedule is? I would say probably not quite, you know, but, you know, all of the tasks that you perform have a much higher consequence if you don't do them, or don't do them to a, you know, normally very exacting level of, you know, specificity. But yeah, it's like, yeah, I wish I could be more comforting, but I think it's more useful for you to hear the truth. Like you've probably got enough people who will tell you, "Oh, it's fine," you know. Um, it's useful to be able to hear the truth from people, and the truth is, life doesn't get easier when you get out of university. That doesn't mean it's not worth it, right? Life does have its compensations. Yeah. And, you know, it is true what they say that to some extent, the amount of like personal satisfaction and meaning that you derive from life is proportional to the amount of responsibility that you voluntarily accept. You know, a lot of people in the university system, I kind of get the feeling that they don't necessarily view their education as like a responsibility that they're voluntarily accepting, but like the thing that they have to do the thing, you know. But you know, if you like, I've been reading Stoic philosophy lately. Like I've been reading the Enchiridion, which is written by an ancient Greek guy by the name of Epictetus. It's like the thing that Marcus Aurelius read all the time, and then wrote the Meditations. But if you're interested in if you're interested in a philosophy that can help you cope, I highly recommend Stoic philosophy. Like one of the precepts of Stoic philosophy is basically the world is just going to give you shit, right? But it's only shit if you think of it as shit, right? Like you are in control to some extent of your perceptions of the situation, right? There's like I was reading this one bit. It's like when life gives you difficult circumstances, think of it like this. Think of it like you're an athlete who's training, and the person who's training you has just matched you with a really good, like, imagine you're training at wrestling and you've been matched with someone who is better than you are, right? It's like, well, you could be resentful because you've been matched with someone who's obviously going to beat you, or you could be like, this is a great opportunity to try to improve my own wrestling technique. If I can get over my ego being bruised by the fact that, you know, I'm obviously going to lose this fight, you know? Like, letting go of your ego is like a really, really, like, once you've learned how to do it, you'll kind of get addicted to it, to be honest with you, because it just makes life so much more livable, you know? And it's really like to some degree, the thing I was talking about with like initiation rites is very often the thing that you have to let go of is like your own preconception that you're any good at anything, which, you know, kind of, it's like, you know, that's all that's keeping me afloat is the idea that I'm maybe not terrible. You know, like people like millennials and Zoomers have a terrible time with imposter syndrome. But, you know, the solution to imposter syndrome is not to puff yourself up to the degree that, you know, you feel you deserve the position you have. The solution to imposter syndrome is to realize that, you know, pretty much everybody else is just as incompetent as you are. You know, pretty much like, you know, Epictetus has a great line, or maybe it's Epictetus quoting Diogenes, but the line is that reputation is just the chattering of madmen, and why would you care what a madman thinks of you? So. Anyway, I think I'm gonna log off here. Thank you very much for your time and attention today, folks, and stay cozy. I'm trying that one out as my new like sign off. Stay cozy. I like it, you know. People enjoy being cozy, especially in the winter. Take her easy.